There we go. All right, so let's go take a look at the first one. So we're going to use the formula. So again, our x bar is 3. So the theoretical formula first is subtract the mean from each one of those, right? X minus x bar. I'm going to go ahead and blank these out. Oops. And we'll get -2, -1, 0, 0, 1, and 2. And then we're going to square all those, right? So square each one of those. So we'll end up with 4, 1, 0, 0, 1, 4. And then we're going to add them up and divide by, kind of average them, divide by n minus 1. Not quite how many there are. There's 6 of them. 6 minus 1. So that will give me 10 over 5, which is 2. That's my s squared. And my s is square root of 2, which is 1.41. Good. All right. Next one. I'm going to work up here. Oops. Over here. Like that. All right, so here I need to, what is it? It's n times the sum of my x's squared. So I need to find that part first. And then we're going to subtract the sum of my x's squared. And then we're going to divide by n times n minus 1. So I'm going to do these in pieces. We'll do the pink piece first. The n times the sum of the x's squared. So I need to find all my x's squared. So my x's squared would be 1 squared is 1, 1 squared, 1 squared, 1 squared, 5 squared, 5 squared, 5 squared. So that's 1, 1, 1, 25, 25, 25. That's the x's squared part. So then I need to sum them. That means I need to add them all up. Use a different color for that. Add them all up. So then that equals 78. And I need to multiply by n. So this ends up being n times the sum of my x squared ends up being 6 times 78. And you guys got 400 and what?
68.
468. Okay, good. Now we got to deal with this other part. That's the first part. Now I got to deal with the sum of the x's squared. So it means I'm going to sum all the, no, it's not. This is the parentheses, sum of the x's squared. That means I need to add them up first and then square them. So it means I'm going to add them up. 1 plus 1 plus 1 plus 5 plus 5 plus 5 and square that. So if I add them up, I get 18 squared. What's that, 324?
Yeah.
Great. So the first part of this is 468 minus 324 divided by n, which is, how many of them are there? 6 times 6 minus 1. So that ends up being, what is 144 over 30, right? 6 times 5. And you guys ended up with 4.8. That's my s squared. So then s is the square root of 4.8, 2.12? 19. 19. Great. So then my next question to you guys is common sense. looking at these guys here. Okay, so did that make sense for everybody? B?
Yeah.
And again, when do you want to use that? On your homework, whenever your mean is a decimal, has a decimal in it, you know, like 3.4 or something like that, you want to use it. Whenever your mean has a decimal involved, if it's not a whole number, whenever your mean is not a whole number, you're going to want to use that one instead. Okay. Number C, common sense. How much do these guys vary from each other? Not at all. 0. So their variance is what? 0. Their standard deviation is what? 0. All right. The last one you guys have is problem number 7. And so here, this person has they've taken 5 classes. The first class was 3 credits and they got an A. The second class they also got an A on. That was 4 credits. The third class they got a B on. It was worth 3 credits. The next class they got a C in. That was worth 3 credits. And the last class they got an F in, but it was only worth 1 credit. So I would suggest that you set it up like this first. Give yourself a little bit of room here. And sort out what you've got. So you're like, okay, I have an A, that's 3 credits. I have an A, that's 4 credits. I have a B, that's worth 3 credits. I have a C, that's worth 3 credits, and F worth 1 credit. Now, you have to go back in and write in how much an A is worth. An A is really a 4, right? So 4 is, how much are the B's worth? 3. C's? 2. And the F? 0. So this is your grade, right? The letter grade and the number part. And this is your credit. And I think that will help you kind of solve it like we did yesterday. You just have to kind of organize a little bit, right? So kind of think of it, remember, the credits tell you how many you have. So my credits, I have 3 credits. That means I have really 3 little A's, 3 little 4s that I need to average. The next one I have 4 A's. So I have 4 little A's running around, 4 4s I need to average. Then I've got 3 B's, so I have 3 3s that I need to average. And then I have 3 C's, so I have 3 2s. And I have 1 0. I need to average all those together. And again, what varies from person to person? What's my variable in this situation? The grades or the credits? The grades. The grades are what varies from person to person. So you do not divide by the grades. You don't divide by your variable. You divide by the other thing. All right, do you guys need just another minute to finish one up, or is everybody done? 1 minute? Okay, I'll give you guys a minute. If you're at home, pause this video until you finish this. Okay. So let's take a look and see what we've got. 4 times 3 is 12. 4 times 4 is 16. 2 times 3 is 9. 6 and 0. I'm going to add those up and get 3. 43. Is that right?
Yeah.
And then again, what varies? What's my variable?
Credit.
Grades. Grades is my variable. So I do not divide out my variable. That's what I'm trying to find. You divide out the thing that stays the same. So it's many credits. So I'm going to divide by the credits, 14. If you're not sure, you can also remember that this comes from, this is 43 what's? Grades times credits. Right? Everybody, is everybody with me about that? How do I get that grades times credits? Mm-hmm. So what do I want? The average grade or the average credit?
Average grade.
Average grade, so I need to get rid of the credits. So I need to divide by credits, 14 credits, and then these guys, just they cancel out credit over credit. I'm left with a grade, average grade. So you guys end up getting 3.14, I believe. Is that right? Oh, no, 3.07. Yeah. Should be 3.07.
I have no confidence with it. I was like, if you say it's wrong, it's wrong.
Have a little faith, guys. All right. So 3.07.
What if you're wrong? wrong with
Good?
It's so funny.
All right.
It's so true.
Okay, so everybody should, hopefully your computers are on, or you have a TI-8384 calculator. Does anybody not have either their computer on or a TI-8384 calculator?
Wait, TI what?
Move over here. TI-83 or 84 calculator.
I have an old one.
You have a calculator, or is it not?
Will this work?
Bang. It's right at the bottom where the bang is. Those are, yeah, those are. Okay, so we'll come back to this one in a minute. So make sure your computer's on. And we'll come back to this one in just a minute. So if you have a TI-83 or 84, hold it up please so I can see it. Or your phone. Okay, so everybody else, you need to have your computer on. Make sure your computer's on. Okay. We're going to come back to this one in a minute. Can you share? No, you cannot share. Everybody has to do their own. Okay. So I want to review the range rule of thumb for estimating minimum and maximum usual values. We did this last class. Right, so this was, remember, if we take our mean and we go 2 standard deviations this way and 2 standard deviations that way, then most of our data lies between these two values. So how to find the usual, the minimum usual value? You take your mean, you subtract 2 standard deviations. How do you find the maximum usual value? You take your mean and you add 2 standard deviations. So really anything beyond that would be sort of unusual. And so what we did last class, if you guys recall, is we did this example. All right, we had a mean of 24, standard deviation of 2.6, and we used the range rule of thumb. And then we also checked to see if 30 chocolate chip cookies would be unusual. And what we found was we take our minimum usual value, we find it by taking our mean, 24.0, and subtracting 2 times 2.6. And I recommend finding 2 standard deviations first. So just off to the side, take 2 times 2.6 first, and then subtract that from 24.0 and add that to 24.0 to find the minimum and maximum. Why? Because people all the time get caught up and they just go straight across and they completely ignore orders of operations and say, oh, subtraction first, and they subtract, instead of, remember that when you multiply first before you add and subtract. So they end up with a minimum of 55. So if my chocolate chip average is 24 chocolate chips, does it make sense for the minimum typical value to be 56 chocolate chips? No, the minimum should not be above the average, right? It should be below the average. Does everyone understand what I'm saying? Right? In other words, if the average grade in our class was 80%, it doesn't make sense that the minimum grade that someone got in class was 94. Right? It should be, you should have your mean, and then you should have stuff, the minimum should be below that, the maximum should be above that. So if you get something like that, that means that you did something wonky with this stuff here. And again, remember, 30 fell above the maximum, so it's unusual, right? Because it's not within 2 standard deviations of the mean. Okay. When we compare variations, so if anybody has gotten the computer up and it's asking for a login, for student, you just hit enter. There is no password. You just hit enter and it goes in. Okay, stop clicking. Okay. Comparing variations in different samples. It's good practice to compare 2 sample standard deviations when their variance is the same. If not, we use what we call the coefficient of variation. So I think this is in your notes, right? You should have written that out. Now, right, when we compare 2 standard deviations, they're approximately the same as we're comparing variation and samples. So you can use either one of those words, standard deviation or variance. I don't care. Variation. You should be filling that into your notes. How do we find it? We take the coefficient of variation, and we find it by taking our standard deviation and dividing it by our average. In other words, what percentage of the whole does our standard deviation represent? So, for example, I have pieces of paper. So say I've got these 3 pieces of paper, right? And I'm looking at their lengths. So these 3 pieces of paper, if I look at their length, their widths, or their widths, they all vary a little bit from one to the other. So if they had a variation of standard deviation of 1 inch amongst them, then that kind of makes sense, right? They all vary a bit from one to the other. That would be a reasonable amount of variation. But if I had 3 buildings, and their standard deviation between those buildings was 1 inch between 3 buildings, that's like they're like exactly the same size. You guys understand what I'm saying? Like 1 inch compared to a whole building means that those buildings are like pretty much frickin' the same size. Versus pieces of paper, right? That's 1 inch variation here means that they vary a reasonable amount. There's some variation between them. So that's why it matters how big your average is. What we care about whether this standard deviation is a large part, large compared to your average, or really small, like a building compared to your average. So, in other words, what percent of the whole does it represent? So that's what the coefficient of variation is. You take your S, your standard deviation, and you divide by the mean, your X bar. And then you change it to a percentage, right? Multiply by 100%. So that's just multiplying by 1. So let's do one of our own. But first we need to find the chocolate chip cookie. So first of all, this wasn't 24.0. It was, what was it, 20, or 23.4 was it? What did you guys get?
It was for the
That's okay. No worries.
Okay.
So let's take a look at our, let's go back. All right, so let's take a look at this problem. Everyone bust out your CIA 83 or 84 calculator. On your computer, you're going to, where do you go? Oh yeah, it's right here. I moved it around before. This little Wabbit Emu guy, it's a little Wabbit. There's the calculator. If you can't find it, type in the search box at the bottom, type in Wabbit with the W, Wabbit, and it'll pop right up. Okay, so you guys should all have it open. Everybody has it open? Yes? Great. I need you guys with me. Does everyone have this open?
Yeah.
Okay, great. Now we're going to go to list. So you're going to hit stat. So stat is right here kind of in the middle. You're going to hit stat. And we want edit. So hit stat and enter. Everybody do it. Again, stat right here kind of in the middle. And then if you want edit, so hit enter in the bottom right corner. Everybody there? You might have something inside your list like I do. If you have something inside your list like I do, then arrow up. So the arrows are right here, these little gray things right there. Arrow up until your cursor is on the L1 itself. So right now the cursor is below the L1. If I arrow up, then see my cursor is right on the L1. I'm going to hit clear right below the arrows and enter at the very bottom. And then it throws it right out. I'll do it again. Arrow up to your on, so you're on L1, hit clear, and then enter, and now we'll clear that list. All right, so then you're going to type in our numbers. What are they, 22? What are they, 22, 22, 24, 26, and 23 maybe? Okay, good. So type in your numbers, 22, 22, 26, 24, 23. I'm slightly out of order, but that's fine. Yeah. Oh, Victoria, can you help him with his computer? Jen? Or help her. Yeah. So guys, this is the lab problem that we skipped last class. So this is it's right below the Model A, Model B. So it's a lab problem right below the Model A, Model B that we skipped last class. So it's 22, 22, 24, 26, and 23. So it's 5 numbers. All right. If anybody has trouble getting them in, flag us down, and we'll help you get them done. Everybody, raise your hand if you've got them in.
I have a question.
Yes.
Does it matter what order they're in?
Nope. Okay. All right. So everybody has them in? Okay, now we're going to hit stat again, right there, kind of in the middle. And you're going to arrow over. You want calc. You see where it says calc here? You're going to arrow over, right arrow, so the right arrow is right here. Right arrow over. So you're on calc and hit enter at the bottom. And it'll give you this prompt, 1 bar stat. Do it. Stat, arrow over to calc, and then hit enter.
What does it mean?
Walk around and show them.
What does it mean?
Okay. Is everybody here? Yeah. Okay. All right, so we want list 1. I can wait till you guys are ready. All right, what list 1? List 1 is this little blue thing right here in the corner above 1. Someone see it? It's a little, L1 is this little tiny blue thing right in that corner. How do I get it? I hit the second key in the upper left corner. Second key will give me, because it's the same color as the L1. So hit the second key and then hit the 1, and that will give you L1. Let me show you. I'm going to look up second, and then 1, and you'll see L1 hop right in here. You guys see that? Then hit enter. Does everybody have it?
Yeah.
If you don't have it, check your neighbors, make sure they have it.
Yeah.
You have it? You both have it?
So go ahead and hit enter. Mine shows up different.
So if you have a high-end TI-84, it might give you list and then frequency list. It might give you 3 prompts.
Yeah.
Where it says list, frequency list, and then something else. So leave the frequency part blank. If there's anything in there, delete it. Clear it. You go down to it and clear it. And then put your list L1 into your list. Leave your frequency blank, and then just go down to the bottom and hit enter. And you should get this. What you'll notice is you've got your X bar, 23.4. You got other stuff. You'll notice it has SX and sigma X. It gives you both your S and your sigma. Here's why. The calculator doesn't know whether you put in the whole population or whether you put in just a sample. Is this a sample or the whole population? Is this all the chocolate chip cookies or just it's a sample? So you know it's a sample. So you know you should look at S and not sigma. Does that make sense? The calculator doesn't know whether this is the whole population or just a sample, so it gives you both. So you know that you want S because it's a sample. Everybody following me?
Yes.
So what's my S? 1.67. Good? Standard deviation. So S is our standard deviation. You do not want sigma, you want S. And you'll notice sigma is a little bit larger, S is a little bit larger than sigma, right? Because sample, you got to make a little bit of an allowance for error. All right, so now we've got it. We have our S is equal to, what was it again?
1.67. 1.67.
1.67, great. So that's about 1.7. But for my calculations, I'm going to go ahead and use, 1.673. I'm not going to round to get to the end. And what was my X bar again? 23.4?
Yeah.
Yeah.
All right, so my X bar is 23.4. My S is 1.673. Everybody find my critical value. Find your critical value. The formula is right above, right here. Use it, find it. Find the critical value. That is obvious. Now I'm doing this one. So the next page, halfway through, find the critical value. Or sorry, not the critical value, the coefficient of variation, my bad. Find the coefficient of variation. And use S is 1.67. 1.67. I know I gave you stuff in there, huh? That's okay. So we're flipping to the next page. We are right below coefficient of variation. The example, yeah.
How many decimals are we supposed to round to find the coefficient variation?
Yeah, it's a little bit vague. It's so not important that I don't really worry about it. So let's take a look. So how do you find it? 1.673. I'm just not going to round. Divided by 23.4. What did you guys get?
0.07.
Give me one more decimal place at least.
Okay, 0.0714.
Yeah. So you would say, as a percent, 7.1% would be fine. So you can leave it like this. I'm okay with that. But so this is the same as 7 cents, right? The 7 is in the cents place. So it's 7% and then some stuff after it. Whatever comes after the 7 goes after the decimal place in the percent. Okay. Yeah. Sorry, it's not critical value. It's coefficient of variation. Yeah, coefficient of variation. Sorry, I'm rambling a little bit.